Let's play this game one more time. We're going to find the x values for which the series n equals 1 to infinity of x to the n over n factorial converges. So we want to know what x values we can plug in to this series and end up with a convergent series. Okay, so we see a factorial, so we should be thinking ratio test. So we're going to take the limit as n goes to infinity, the absolute value of an plus 1 over the absolute value of an. Alright, so this is going to be the limit as n goes to infinity of the absolute value of x to the n plus 1 divided by n plus 1 factorial. Rather than dividing by the an term, we're going to multiply by the reciprocal. So the reciprocal is absolute value of x to the n in the denominator and n factorial in the numerator. We're going to regroup. Putting all of our like terms together, we get absolute value of x to the n plus 1 over absolute value of x to the n times n factorial over n plus 1 factorial, which is n plus 1 times n factorial. And now we have the great cancellation. So n factorial and n factorial are going to cancel. X to the n plus 1 over x to the n is just equal to x. So we get the limit as n goes to infinity of the absolute value of x times 1 over n plus 1. No matter what x is, this limit as n goes to infinity x is constant in this problem. We're varying n, not x. So we have x times the limit as n goes to infinity of 1 over n plus 1, which is equal to absolute value of x times 0. Okay, so our limit is equal to 0. Notice this is less than 1. No matter what x was. So the function f of x equals the sum from 1 to infinity of terms x to the n over n factorial has domain of R. This is always defined. All right. That is all, folks. All right, and I should have said this last piece that I always want you to include in your solutions. So we took the limit of the ratio of the terms. We got 0. We said this is less than 1. Now the conclusion is that by the ratio test, our series converges. And it did not depend on the x value we put in. Okay? So whenever we use a test, we need to wrap it up, say what tests we used and what our conclusion is. Great. Have a good night, folks.